Hello and welcome back to the next part of computer science, and today we're going to be looking at logic gates and truth tables. So logic gates and truth tables, we need to understand what these are for computer science. It's a little bit of problem solving based on what we were doing last week and taking it a stage further, so you're going to have to try and solve a few tasks as we go through this lesson. So what we have here is we're going to understand how logic diagrams work, we're going to be able to draw them ourselves, and to understand truth tables, this bit we come on to next week's lesson rather than this week's lesson, but we're going to look at truth tables in turn. So before we get on to this week's lesson, we're going to have a quick recap of the solution from last week's problems. And there's a couple of ways I asked you to solve this: a visual representation of the task. And what I've got here is one piece of work that was submitted in where I could see that somebody has obviously moved bits of paper across the paper to work out how to solve it. And on the left here is Mr. Dowse's version. Now this is fairly simple and straightforward. We start with the visual representation of all the items on one side of the bank, and we can see here that the man and the goat go across, the man and goat end up on the other side of the bank, and then the goat gets left and the man goes back. So now you have the goat on one side and the man, the hay and the wolf on the other bank. The next stage is to take the hay over. So as the man takes the hay over, he cannot leave the goat and the hay unsupervised because the goat will eat the hay. So the man takes the goat back. So he's left the hay on one side and he's ended up back on the other side with the goat and the wolf. That's fine as they're supervised. So now the man takes the wolf back over, and the man can go back, collect the goat, go back over, and they've all reached the other side of the bank, completely supervised, and the solution to the problem is there. So I've seen lots of different ways it is visually represented. Many people got the correct answer last week. Really good to see that people have spent the time to try and draw out visually how to represent this problem. So really good to those people. The second problem, the camel task, was a little bit more difficult. Now again, Mr. Dowse's version here, you can see the blue and the red, and you can see that this camel here has moved forward. So it's moved forward, and then you can see that this red camel has jumped over, and so on, to eventually you end up with the 4 camels on one side and 4 camels on the other. Now what I have here is a video that was sent in to me showing exactly how to solve this in the same way. Really good example. I'm not going to play the whole video, but you can see here another way to represent this by drawing it out on bits of paper, and that trial and effort method, that brute force method that we spoke about last week, gets represented here. Once you've got a solution, then you can visually map it out like Mr. Dowse has done here. So really good work observed last week. I'm going to move on from this. So let's have a look again at what we're trying to achieve this week. So it's back to logic diagrams and you drawing a logic diagram. So what I've got here is a little bit of background understanding we need to know first is about this man here, George Boole. Now he invented Boolean logic. Boolean logic is when there's a Boolean value is there's a true or false, a yes or a no, or on or off. It's one or the other. There is only one option or another option. So it all relates back to this man here, George Boole, who lived quite some time ago now. He was born just over 200 years ago. So this logic, this computer logic, has been around for a long time, and it's what the basis of computer science is, how computers work. Now lots of different logic gates you need to understand, but the only 3 that we have to have a real understanding of is the AND gate, the OR gate and the NOT gate. I'm going to go through these 3 different gates, and you're going to do some work today based on these. So first of all, let's look at an AND gate. Now I'm going to draw an AND gate. So whenever I draw an AND gate, I draw it like the letter D. And I remember that when you write AND, you got the D in it. So that's how I remember what the AND gate looks like. So again, the D shape looks like this. Now we can see here that we have 2 different inputs and 1 output. Now for an AND gate to work, this input here and this input here both have to be on. Now we can represent on as a 1. So this input's now on and this input is now on, which means the output will be on. If I did another AND gate and I have an input at the top here as off, which is the 0, and this one here as on, because both of the inputs are not on, the output is off, which is a 0. And that's kind of an understanding of this. You can go back, rewind this bit and look again, just to play again if you need a bit more understanding. But what I have here is an understanding of an AND gate, and it could be that you've got a burglar alarm. So if the sensor is triggered and the alarm is on, because it's an AND gate, the burglar alarm will sound. Now what I'm going to show you next is a piece of software called logic.ly. So I'm just going to go on to a browser and type in logic.ly, and when that loads, this top option here is what we're looking for. There is a free trial, so we can use this one, the free trial, and you don't need to download it. All you have to do is try it in a web browser. So try Logically in your web browser, and what that opens up is a version here. We can close this bit. So we have a version here. Now I can put a switch like I did before and another switch. I'll just drag those in. And what I'm now going to put in is my AND gate. Remember here, it looks like the letter D. I can join this switch to this node here, this switch to this node here, and what I'm now looking for is an output. So this is like the diagram I drew before. I've just connected my parts of my circuit together. Now remember we said that both inputs have to be on for the output to be on. So I can switch this switch on now. Nothing has happened to my light switch because I've only got one of my inputs on. When I switch the second input on, the light switch switches on. So this input and this input cause this output to work. So if I switch one switch off, it won't work. So this is using logic.ly, and this is one way that you can do your work this week and screen print that and send it in to me. So if you didn't want to use logic.ly, what you can do is draw it by hand, take a photograph of that and send that in. And what I'm looking for is examples of the AND gate. So if one input's on, if the other input's on, if both inputs are on and both inputs are off. You after that going to show them for the OR and the NOT gate. So what I have here is an example of what I'm looking for the AND gate. Both inputs off, one input on, still off, one input on, still off, both inputs on, the output is on. So this is what I'm looking for you to produce either by hand or using logic.ly for the AND gate. Once you've done that, we can then look at an OR gate. Now an OR gate means that if this input is on or this input is on, the output is going to be on. So what I'm going to do now is just show you an OR gate, and the way I remember this is, to me, that looks a little bit like a shark. Now if you're in a boat and you see a shark, you might need to defend yourself, and you can defend yourself with an oar on the boat. So that's how I remember this shape being an OR gate. We've still got our inputs and an output. So here I've got both inputs being off as zeros, which means my output is off. I can have another input. If one is on and one is off, doesn't matter, the output is going to be on. This or this need to be on for the output to be on. So there's two other gates. I'll give you a little clue as to what I want to see here. We're going to have off and on, and you need to tell me what goes in this box. And the last one we've got the other option we can have is if both of them are on, what will the output be? So you need to fill in this box with a 1 or a 0. So that's the task for the OR gate. I hope that makes sense. What we now have is the task for the NOT gate. So NOT gate looks like a triangle, and what this does is whatever the input is here, the output will get changed to the other value. So if the input is on, the output is going to be off. If the output is on, the input is off, the output will be on. So if it's a 0 here, it'll be a 1 here. If it's a 1 here, it'll be a 0 here. So it just changes the output. So there are only two. If we look back at the NOT gate, there's only two variations of this. It's either a 1 or a 0, so there are only two different outputs. There's only two different things we can draw for the NOT gate. But again, if you can draw that in logic.ly or by hand, take a photograph, put it into your ePortfolio, that'll be brilliant. So what we're now looking at is I'm going to walk you through this example here. So let's have a look at the visualizer again. And this time I often find it useful to draw these out at the same time. So I've got an OR gate to start with, and we've got the word on. I'm going to change that to a 1, and we've got the word off. Now we need to know what the output is. So remember, it's an OR gate, so only one of them need to be on. We've got one on, so our output here is on. This then goes off, and we've got a 1 here that goes to our AND gate. Now for an AND gate, remember it looks like a D, both are on. So is this on and this on, therefore our output will be on. Now here we've got a NOT gate. If we look over on the computer screen, and it starts off as off, which is 0, which means our output becomes a 1. And this then goes to this AND gate here. So which is on and on, which means our output will be on. So what we can then do, we now know that the final output is on. And that's how you solve these logic problems. So I've got a series of them here that you can pause the film, work these out, and you need to know the answer for each one of these. I'm going to do the first one with you just as a recap. So again, we've got this shape here that looks like a D, so it's an AND gate. And we've got another one, another AND gate. So we're trying to work out what this is here. So we've got one that's on, one that's off, and one that's on. So this is an AND gate. Are both of them on? Is this and this on? Well, it's not. So that is a 0. This one here, we can carry over the one here. So are they both on? Well, they're not. So this is a 0. So our answer is off. And what you need to do is work through these 10 examples and then complete your answers in here, showing your 10 different answers that you get. So that's the task for this week, to show the different and or NOT gates and to solve the 10 questions, what the results will be. As usual, you can add all your information into your ePortfolio and send that to Mr. Dowse and myself. If you've not sent a piece of work over the previous weeks that we need to mark, then please send that in to us as well, so that you're fully up to date. And lastly, don't forget to subscribe to this YouTube channel so that you can get the video straight away when the next video is produced next week. Good luck with your work this week. The work last week was superb. I'm hoping this is to exactly the same standard, and I look forward to seeing your submissions.